In this video, we're going to complete that 4x4 determinant that we started at the end of the last video, where I just kind of used it to illustrate some of the key properties that were established. So now we're actually going to go through and do the full evaluation of this 4x4 determinant, but we are not going to use any cofactors at all. We're going to use exclusively our row operations. All right? So the first thing I'm going to do is it's convenient to have a 1 or a -1 as a pivot. It's not necessary though for these determinants. It's more of a luxury than a necessity. But anyway, I'm going to do a row swap and swap row 1 and row 4, right? And by doing that, by performing a row swap, I know the determinant that I'm going to write down over here is going to be the opposite or the negative of the one that I started with. So I'm going to have to keep track of this negative sign. So I'll put my -1, -1, 6, 11, and then 8, 1, 0, 0, and then 4, 4, 7, 10, and then 3, 1, 2, -9, right? And remember, our goal is to make this triangular. It doesn't have to have pivots on the main diagonal. We just want it to be triangular, and then we can use that property of triangular matrices where their determinants are computed by multiplying the entries on the main diagonal. So our goal is to eliminate these 6 entries, right? Well, let's go ahead and eliminate the 8, the 4, and the 3. So this is equal to, let's see, so if we take 8 times row 1 added to row 2, 4 times row 1 added to row 3, and 3 times row 1 added to row 4, none of these operations will affect the determinant. Anytime you do a constant multiple of one row added to another row, the determinant stays the same. I will have to bring down the negative sign, right? But what I'm guaranteed is that this determinant here is going to be identical to this new determinant here, but it's going to have a lot more zeros, right? So let's write down the first row. Here we go. Second row will become 0, -7, 48, and then 88. Third row will be 0, and look, we're going to eliminate this as well. So we're going to almost like a 2 for 1, and then this will be, let's see, so that's 24 plus 7, so that's 31, and then 44 plus 10, that's 54, and then this is going to be a 0, and then -3 plus 1, that's -2, 18 plus 2, that's 20, and then 33 minus 9, that's 24. All right, so we've made really good progress. I mean, we've eliminated a whole bunch of entries right here, right? And we also eliminated one here. So basically, to make this determinant triangular, I need to eliminate the -2, and I need to eliminate the, well, probably whatever entry is going to end up being right here as well, right? Once I do that, then it will be triangular, and I can simply multiply the elements on the main diagonal. Now, this is where I often recommend, if you're using the determinant, or if you're using row operations to evaluate a determinant, having a pivot of 1, again, is not a necessity. We simply need to make it triangular. So what I'm going to do is complete this process, not necessarily getting a pivot of 1 here, but just showing how you can eliminate these entries without having a pivot, right? So we need to figure out what the constant is that I need to multiply row 2 by. So when I add it to row 4, we'll eliminate this. And the easy way to remember it is this. The entry that you're trying to eliminate, take the opposite of it. So take a positive 2 and then divide it by your pivot. So if you do this, if I take negative, or let's say it's going to end up being negative, but if you take a positive 2 divided by negative 7 times row 2 and add it to row 4, it will eliminate this entry, because multiplying up negative 7 by negative 2/7 will give me a positive 2, which is the opposite of what I want here, right? If you had a pivot of 1, then in the denominator here, you would just have a 1, so you always have these nice integers. But if our goal is simply to eliminate the terms and not necessarily have a pivot of 1 along the main diagonal, then you will have to do more operations that look like this. So I wanted you to see what it looks like, right? But the fact is, this operation does not affect the determinant. Again, bring down the negative sign, and let's write down the result. So we know the first 3 rows will not change, right? So -1, 6, 11, 0, -7, 48, 88, 0, 0, 31, 54. Now the 4th row will change. We'll have 0. We'll get a 0 there. And then this becomes 44 over 7. Not a really convenient number. And then this is -8/7, right? And this is what it tends to look like when you have constants that look like this, right? But it's kind of a trade-off not having to do the constant multiplier rule, right? Okay, so it's almost triangular, almost. What we have to eliminate is this this positive 44 over 7. So again, the rule is whatever entry you're trying to eliminate, take the negative of it and then divide it by what would be your pivot, right? So it's going to be negative 44 over 7 divided by 31 is going to give me negative 44 over 217. Right? Again, not the type of constant that we typically use, but it works. It really does work. So then this is times row 3 added to row 4. And again, we know that this operation will not change the determinant. So bring down the negative sign. And so now, again, the first 3 rows won't change. Right, like that. 0, -7, 48, 88, 0, 0, 31, 54, 0, 0. Then I know I'm going to have a 0 here. And then this entry now, again, not a nice entry at all, but it's what it is. It's negative 2,624 over that 217, right? Not pretty, but I wanted you to see it, right? And again, beauty is in the eye of the beholder, right? So if your eyes are beautiful, this will be beautiful. So, but the whole point is now it's triangular, right? This is now upward triangular, and then we can utilize that property that says all I have to do is multiply the elements on the main diagonal. So what does it look like? Well, the negative sign continues to come down, so I'm going to have negative. Then I'm going to have -1 times -7 times 31 times -2,624 over 217. And then we have 4 negative signs there. That's an even number of negative signs, so everything's going to be positive. Not just that, but the 7 times 31 is 217. So it's going to cancel out that denominator. And we're going to end up with 2,624 as the determinant of our original 4 by 4 determinant, right? There is no way, absolutely no way, we would have been able to compute it this quickly and this efficiently and, you know, accurately if we were to use cofactors. We would still be working on our cofactor expansion if we didn't take this approach of using our row operations, right? So it's a very, very handy tool, and from a practical standpoint, evaluating large determinants, it automatically means, okay, let's do some row operations, let's eliminate some terms and reduce the amount of computation that we'll have to do, right? So go ahead and try some and have fun. See you in the next video.